On our last visit, the construction phase was just kicking off, and the site looked like this.
And you might think with flat open ground, they could just start stacking floors.
But as we found out on our second visit, there's a lot more to it than that.
Let's take a look.
Our second site visit actually started out at home. Since we aren't on the job site every day, we thought it'd be a good idea to review safety practices. Workers complete safety training, have regular safety meetings, file safety plans for the tasks they're working on, and are supervised to make sure procedures are followed.
One of those procedures is to complete site-specific safety training.
The standard safety policies apply to all Manhattan work sites, but because each work site is unique, additional safety instructions and rules specific to each job site are developed. This training includes, but is not limited to, where to meet up in the event of an emergency,
Also called a muster point.
procedures to follow in the event of an accident, and any hazards, special equipment, or areas of special need that they may encounter on site.
Everyone that goes on site, including us, is required to have site-specific training.
After we completed that training, we put on our PPE
That stands for Personal Protective Equipment.
and toured the site. The first thing that we discussed were the utilities. Not only does the new building need utility connections, there are existing sewer and electrical lines that run underground where the new building will sit.
The existing lines serve the existing hospital campus.
So our utility guy over here, he's putting in brand new sewer piping because you can't leave the old sewer piping underneath the new building.
Oh, so that's existing sewer pipe.
So this is existing sewer piping. So one of the first things we had to do, we have to get our utility guy here. He's going to tie into that existing sewer piping that comes off of those buildings. We're going to reroute it all the way around our new building, all the way back over there by the Sonic and that tree. So we have to get it out of the way so we can start putting in our new foundations at our new building.
I see. So basically, we're already building something new, so let's use this as an opportunity to make some of the old pipes here, single pipe here, new.
Well,
Exactly.
yeah, they don't want it on the new building in case they need to work on it.
Because these cages and these piers right here, they go directly between that clean out and that other one right down there. So it's highly likely that if I went and just drilled a hole, if we drilled through that existing sanitary sewer piping without having the new loop in, we would have a pretty bad backup inside the building.
This is our new sanitary sewer that'll take all the sink water, the toilet water, all the stuff from the new building, and it will route it all the way around to the city sanitary sewer main.
As you might suspect, there are specialty utility services for this type and size of building. For instance, there are 4 water supplies: a regular water services line, a hot water line, a chilled line, and a fire suppression line. At your residence, your water meter might look something like this.
For this building, the water connections will occupy an entire room.
You may be wondering what internet service to the building looks like.
We are too. But we didn't think to ask. So we'll put that in our questions for next time. If you have questions, put them in the comments. We'll try to find the answers.
In addition to the utility work, the earthworks phase was underway. There are all kinds of soil types. Soils are made up of 3 particle sizes. Sand is the largest particle, clay is the smallest particle, and silt, which has a size in the middle. How much of each type of particle determines the type of soil, and different types of soils have different properties. For construction, we want a strong, stable soil, and the specifications for that are determined by the geotechnical engineers.
Geotechnical is civil engineering related to soils and rocks.
These engineers took soil core samples from around the build site and analyzed the soil. They also looked at the specifications for the building design to determine how the soil needed to be prepared for the building's foundation. With a plan in place, dozers scraped off the top layer of soil, which is being hauled off-site and stored. As topsoil is needed throughout the project, it will be reused.
The bulldozer scraped down the earth to a precise, even level.
We wondered how these big machines can hold a precise level over such a big area, and they had an answer for us. The earth-moving equipment is connected to GPS and a field triangulation system to control the blade depth. Wherever it goes on the site, this system keeps the digging at the exact depth needed. Once scraped, the area is tested for any unwanted variations with a test called proof rolling, and the way they do it is both simple and effective. A loaded dump truck drives back and forth over the site. Its tracks are observed throughout the test. The truck is so heavy and the load is concentrated just to its tires, so any loose soils, underground voids, or other issues will show up as uneven ruts. After the proof roll test, a special soil mixture called Select Structural Fill is hauled in and spread over the pad area.
This is what they call a select fill. So it's soil material that has specific properties for bearing capacity that the building can sit on, basically. So we took off a foot of the existing soils, recompacted, and then we brought in a select fill material that gets compacted in order to support the structure.
But having the right soil on top is only part of the preparation. It must be compacted to the right density, and the moisture must be within a set range. These specifications come from the engineers. Compaction is the job of this machine, called a sheep's foot compactor.
The tracks it leaves behind looks like a herd of sheep have passed through.
If the moisture is too low, it can be added via a water truck. If the moisture is too high, it takes some dry weather to help out. This is just one more reminder that the weather is a wild card, and though it can't be controlled, it has to be managed. To make sure the compaction and moisture are within the proper specs, a testing company performs on-site tests at several places over the pad site.
The machine used is nuclear-based and called a Troxler.
A 12-inch deep hole is made into the soil for the testing probe. Gamma rays are transmitted from the probe to a detector, which analyzes what it collects and uses that information to calculate compaction and moisture. The results determine whether the soil is good to proceed or if additional prep work is needed.
If all goes well, this whole pad site will be ready in about a week.
But anytime the pad is disturbed, like any trench work, it will be recompacted and retested. The soil isn't the only thing that will be supporting the building's foundation. There will also be 170 plus piers. Like how an ocean pier is supported by columns sunk into the earth, this foundation will be supported by columns down to the bedrock too.
This building right here will be on conventional concrete piers. We have 170 plus piers.
You know what a pier is?
Pier.
Let me ask you.
That's a pier.
He'll explain better than I
A
can.
pier is an underground concrete column. Let's see. So our piers are as small as 2 foot in diameter, up to 5 feet in diameter, and they're going to go about 65 feet in the ground.
And what do they do?
They're going to hold up everything.
Every single aspect of it.
How do you think they dig 65 feet down in the ground?
A big drill, what we call an auger or a drill rig.
Now, are these for the piers?
So these are for the piers. So these,
They just spit it out.
rebar cages, the ones we have here are specifically for our tower crane foundation. So the first piers that we will put in will support the crane. That's going to do all the heavy lifting for the rest of the pier operation, all the concrete and steel structure.
So, buddy, they'll pour concrete around all this. Remember when we went to the DeLisi plant and watched it mix concrete? It gets poured around.
So we're going to drill a hole that's a little bit bigger than this. And then once that hole makes it down to bedrock, we'll go into the bedrock a little ways. And then we'll use the crane to put this inside the hole. And a concrete and a pump truck will start filling this concrete up from the bottom up.
Because soils are dynamic,
That means they can move.
the piers support the foundation and allow it to float on top of the soil.
We will see more about the piers in later episodes.
If you haven't already hit the subscribe button, now's a good time. That way you will get notified of all the new episodes in this series, as well as our other learning adventures.
As always, thanks to Manhattan for this amazing learning opportunity.
We can't wait to see the progress made each month.
See you on the next part of this adventure.